Welcome to Technology E&E. Today I'm going to break down the components on a motherboard, and specifically the Voltage Regulator Module. This is the X299 MEG Creation workstation motherboard. The purpose of a voltage regulator module is to take 12-volt input and break it down to voltage that a CPU can handle, usually something less than 1.5 volts, as anything higher can severely limit the useful lifetime of your CPU, and it requires dry ice or liquid nitrogen cooling. First, let's start with the Voltage Regulator Module phase controller. It is an IR35201 8-phase controller. MSI advertises this as a 12+1 VRM, which means it is running in 6+1. More on that math in a moment. The controller is near the top of the line that you can get from International Rectifier, although it has been topped on the product stack by the Infineon XDPE 132G5C 16-phase controller. The +1 is for the VCCSA rail, which is a minor power rail to the CPU. The controller features dynamic phase control and automatic power state switching. It also offers temperature, current, voltage, and power sensing features on it. There is also overcurrent protection, under voltage protection, over voltage protection, over temperature protection, and other protections. These protections are useful when trying to fine-tune tricky overclocks that may fail with inferior voltage regulator modules. And for those wondering, International Rectifier is owned by Infineon Technologies. The main components of the voltage regulator module circuitry are outlined here in red, and the chips in the rightmost column are the power stages. The power stages that take 12 volts from the power supply unit and break it down into 2 volts at the VCCIO are TDA 21472 smart power stages from International Rectifier. They are rated at 70 amps and have an integrated gate driver and high and low side MOSFET on a single 5mm by 6mm package. There are 12 of these chips that feed the V-core on the CPU. For Intel, exclusive to the X299 CPUs, they have integrated the voltage controller on the die. This means that the 2 volts at the VCCN are further broken down to the approximately 1.2 volts at a CPU runs at stock speeds. This system of voltage control is the most superior on the market because the voltage the CPU desires is determined on die and doesn't run the risk of being disrupted or degraded on its journey from the VRM to CPU transistors. The smart power stages have several features that make them smart, including current sensing with temperature compensated reporting, cycle by cycle current protection, deep sleep mode for power saving. These are some of the top power stages on the market, and as with many top components, they first appeared in the enterprise server space. Back to the phase count, each 2 power stages are connected to a doubler, so the 6 phases are doubled to 12. Therefore, all 12 power phases can run out of sync, so this is a true 12-phase VRM. The phase doublers used here are the IR3599s. They can double or quadruple the phase count. However, they are mostly used as doublers. These doublers don't do particularly much other than take the phase frequency and divide it in half for each smart power stage. But they don't need to do much more than that because the IR35201 can still sense and balance through them. Unique to this motherboard and its immediate siblings are the use of 3 EPS 12-volt connectors. This means that the PSU cables can handle over 1,000 watts. However, it is seriously unlikely that you'll be able to reach this because at your VCCN you would be pulling over 500 amps at 2 volts. This is not going to happen unless you're using some exotic form of cooling. A normal power user only needs to fill 2 of the slots and can realistically get away with only filling 1.5. All else equal, the 3 slots, if filled, will simply act to make your power cables cooler and marginally more efficient. This feature is mostly a gimmick, but enthusiasts nonetheless may like it. It is a dual phase. The power stages are CSD87350s from Texas Instruments. They are rated at 40 amps and have peak efficiency around 25 amps. This is more than enough current for RAM. If you look closely, the top power stage circuitry, it appears to have only 2 capacitors attached to it, whereas the bottom one has 4 capacitors. As I'll show in a second, this is about to get even more odd. These power stages are controlled by the Premion PV4210 dual-phase synchronous buck controller. Premion is a subsidiary of Infineon Technologies. However, it appears that ROM Semiconductor either owns the patent or is manufacturing and or distributing it on Infineon's behalf. Now back to the oddity I notice. Marked by the number 1 is a capacitor on the back of the board that appears to be a part of the 2 seen on the front. To me, it appears that the top set of memory banks has 3 capacitors and the bottom has 4. If this is correct, the only reason I think this might exist in this way is the top power stages are closer to the CPU than the bottom one. If you folks in the community have any explanations I am missing, or better yet, misinterpreting, please comment below. Is the VCCIO. It uses the IR35204 4-phase controller capable of running in 3+1. Here it is running in 1+0. Power stages are once again the CSD87350s. This is more than enough power for this rail. The gate driver is a CHL5810, alternatively called an IR3537. Here is the DDR-VPP rail. It is a minor rail for the RAM. It used to be integrated on the RAM sticks in older versions of the DDR standard. Here outlined in yellow is another very minor rail for the CPU voltage. It consists of LDOs, or low voltage dropout regulators. Now let's get to the motherboard features that differentiate product line SKUs and price outside of the voltage regulator module. This motherboard also has a BIOS switch, which is helpful if you brick your BIOS. It also has a power and reset switch, which is helpful if you are competitive overclocking or like to make sure all your components work before you go through the process of putting everything into a computer case. This motherboard has 8 4-pin PWM fan headers. This is highly valuable if it means you do not have to purchase a separate hub controller for them. It also means you can program the fans in the BIOS instead of with software in the OS. For the PCIe lanes. This is highly unnecessary due to the fact that 4 GPU setups have largely become irrelevant. Though I suppose if you have that many GPUs for science or something, then it might be useful. For water cooling enthusiasts, there are temperature and flow sensors built into the motherboard. This board also contains a Realtek 8125 2.5 gigabit Ethernet port, which I suppose is better than a 1 gigabit Ethernet port. But Realtek's chips are considered inferior to Intel's. This also requires you to have a router that can transfer these speeds as well. There are 4 RGB headers scattered across this board. There is 1 4-pin RGB LED connector, 2 3-pin rainbow LED connectors, and 1 3-pin Corsair LED connector. So if you desire a board support for these features, then these headers will help you avoid having to get an additional hub controller. Lastly, I would like to praise MSI for the location of their debug indicator. It is easy to read and is located in a spot that won't be covered up by a long GPU or other components flying from your motherboard. There are also 4 LED lights that tell you where in the boot process you may have encountered a potential failure. Since I started production on this video, MSI has released several new X299 motherboards to coincide with Intel's launch of Cascade Lake X CPUs. For example, the new Creator motherboard features 90 amp power stages as opposed to the 70 amp power stages reviewed here. They also have different versions of the board that comes with 10 gigabit Ethernet chips built into the motherboard. One additional housekeeping note with the MSI MEG Creation reviewed in this video, it also comes with several attachments and add-in features that were not reviewed here because the copy of the board I obtained is a refurbished version and didn't come with them. In conclusion, when buying a motherboard, pay attention to the VRM components. Review sites usually do a good job of pointing out these things. But if you want to do your own analysis, you can usually find high-resolution photos of motherboards on the internet. Generally, the more phases that your VRM has, the better it will be, but pay attention to the marketing because sometimes they will try to mislead you. And remember, the boards with the best components usually cost the most. If you like this video, please hit thumbs up and please subscribe to this channel for more tech content. I plan to upload at least once a week. Also, make sure to leave your comments and questions below. I appreciate the feedback because it'll help me create better, higher quality content.